Hello, good morning to all. I am Arjun Sooraj. Today I am going to talk about a different topic, which is dark matter. So first, before we talk about dark matter, let's talk about matter. What is matter? So, matter is anything which has mass and occupies space. Or we can say that it has mass and it also has volume. So, what is dark matter? Dark matter is basically matter, but it does not reflect, emit or absorb any light. So it's basically invisible matter. So scientists say that dark matter is all around us and that there is a lot of dark matter in our universe. So let's see how much dark matter is there in our observable universe. What is observable universe? So, observable universe is the part of the universe which we can observe. 5% of the observable universe is visible matter. Or the matter, or we can also say that it is the matter which we can see and touch. And 27% of the observable universe is dark matter. And 68% is dark energy. So, how did we find dark matter in the first place? For that, let's talk about galaxies. So, let's talk about the Andromeda galaxy, for example. Galaxies rotate and different parts of the galaxy rotate at different speeds or different velocity. So, let's look at the rotation curve or a rotation graph. So in this graph, in this axis is the velocity or the speed. So the velocity is shown in kilometers per second. So this velocity tells us how fast that part of the galaxy is rotating. And in this axis is the distance. It is shown in light years. The distance tells us how far is the part of the galaxy from the center to that part. So, for example, the 10,000 light years distance basically tells us that we are talking about the part of the galaxy which is 10,000 light years away from the center of the galaxy. So, this grey dotted line is the expected rotation curve from the visible disk of the galaxy. The visible disk of the galaxy means, if we are talking about Andromeda galaxy, that means that it basically shows us what the rotation curve of the Andromeda galaxy will be if there was no dark matter. Here we can see that the graph actually peaks at about 10,000 light years. Then it slowly starts to dip. So this means that the most of the stars in that galaxy is present 10,000 light years away from the center of the galaxy. When a galaxy is rotating, that means that there are mainly two forces acting on it. There are many others, but the main forces are gravity and the centrifugal force. So, the centrifugal force is the force which acts outwards and gravity is the force which acts inwards. So, both of these forces counteract each other. So, for a galaxy to be stable, the centrifugal force and the gravitational force should be equal. So, if the centrifugal force is less, then the galaxy would eventually shrink. The centrifugal force increases as the rotation of as the rotational speed of the galaxy increases. So a faster rotating galaxy will need more matter or more gravity to be stable. And gravity also decreases as the distance increases. So, in this galaxy, most of the stars and gases are present in the region of 10,000 light years away from the center of the galaxy. Most of the stars and the gases are present in the region of 10,000 light years away from the center of the galaxy. After 10,000 light years away from the center, there are lesser and lesser stars. So, the gravity will also be less. So, because the gravity is less in the outer parts of the galaxy, those parts of the galaxy should rotate slower than the inner parts. Because if they rotate faster than the inner parts, the gravity of the galaxy wouldn't be able to hold that stars and that matter from orbiting the center of the galaxy. So, they might escape the galaxy. So, after the 10,000 light years, all the stars and the matter actually orbit around the center of the galaxy much slower. That is the expected rotational curve from the visible disk of the galaxy. But what we observed from the galaxy is much more different. So, this white line is the rotational curve which we have observed. So, here we can see that as the distance is increasing, the velocity or the rotational speed is also increasing, which means that there should be more matter or more gravity in the outer parts of the galaxy. So, when we observe the galaxy, what we find is most of the stars and gases are present in the region of 10,000 light years away from the center of the galaxy. But the observed rotational curve says that there should be more matter in the outer parts of the galaxy. But when we observe the galaxy, we don't find that. So, we think that there should be some invisible matter which we have not observed. And there is a lot of that invisible matter in the outer parts of the galaxy. So, we call that invisible matter as dark matter. So, for example, in the Andromeda galaxy, if the dark matter suddenly disappeared, then there wouldn't be enough gravity to hold the stars and the gases within the galaxy. So, the stars and the gases will just escape the galaxy due to the lack of gravity. So, there is a lot of dark matter in our universe. And we can see that from the 0 light years mark to about 15,000 light years, it is shown that it's observations from starlight. And from about 20,000 light years to infinity, it is shown that there are observations from 21 centimeter hydrogen. This means that most of the stars are from the center of the galaxy to about 15,000 light years away from the center of the galaxy. So we can observe their rotational speed just by looking at the stars. But after 15,000 light years away from the center of the galaxy, there are lesser stars in those areas. And there are more dark matter and more gases. So, we observe the gases which are there in that part of the galaxy. There are more dark matter than ordinary matter in a galaxy. So, this was the first evidence that there is something which is invisible, and we started to call it as dark matter. We can also observe dark matter by something called as gravitational lensing. We will talk about gravitational lensing in detail in another talk. We don't exactly know what dark matter is, but there is a lot of research going on about dark matter. We are also trying to find dark matter in Earth itself. I hope you all liked my talk. If you liked it, please like, share and subscribe my channel. Thank you.